Today, we're going to talk about binomial probability distribution. When it comes to random variables, X, you either have a discrete random variable or you have a continuous random variable. A discrete random variable is also called countable. Example of discrete random variable is the number of students who are online in this class. For a continuous random variable, that variable X takes on values on an interval. These numbers are very close to each other, so we cannot actually count them. Example are volume and also area. We have more examples associated to continuous random variable. We have IQ scores as well, and more examples. Shoe sizes, height, weight. These are examples of continuous random variable. Today, we're going to focus on discrete random variable, and later we're going to work on continuous random variable. When it comes to discrete random variable, we have a very famous probability distribution that we call binomial probability distribution. So our goal today is to use our TI-84 calculator and compute binomial probability distribution. First of all, when we are talking about a binomial experiment, the binomial experiment must satisfy the following conditions. First of all, we have fixed numbers of trials, which we denote by n. For example, you have 8 patients that you want to perform surgery on. 2, the probability of success is the same in each trial. We denote the probability of success by P. The probability of failure is denoted by Q, which is 1 minus P. So Q is the probability of failure. The third condition is, well, these trials are all independent from each other. Independent from each other. What's the meaning of that? So assume we have 8 patients and we're going to perform surgery on 8 patients. Surgery on one patient has nothing to do with the surgery on the other patient. They are independent from each other. And finally, the last condition, random variable X counts the number of successes. So if I ask you to count the number of successes in our example of surgery with 8 patients, if n is equal to 8 patients, and suppose the probability of success from past studies is 90%. So just one example that we have. The probability of failure is 1 minus 90% or 10%. The random variable X counts the number of successful surgeries. You might have no successful surgeries, so 0 successes. Or you might have 1 successful surgeries. Or it might be 2 successful surgeries. 3, 4, or 5, or 6, or 7, or all of your surgeries are successful. So random variable X, which is discrete random variable, counts the number of successes. 0 means no success at all. one successful surgery, 2 successful surgeries, and so on. But the question is, how do I calculate the probability? First of all, you have a calculator and you have a formula for probability distribution of binomial that is defined as P of X equals to, you have n factorial divided by x factorial, n minus x factorial, p to the x, and q to power n minus x. This formula is already built into your calculator. So in this class, you don't have to actually use this formula. It's already in your calculator. But just a quick review, what is the meaning of factorial, this exclamation mark? In math, we define 0 factorial to be exactly 1. 1 factorial is defined as 1. 2 factorial is defined as 1 times 2. 3 factorial is defined as 1 times 2 times 3. 4 factorial is defined as 1 times 2 times 3 times 4. We can continue this process, and eventually we define n factorial, as you can see on the numerator, as the multiplication of 1 by 2 by 3 by 4 by 5, and we stop at n. So n factorial is compact version of this expanded multiplication. But again, for our class, the probability distribution for a binomial experiment is already built into your mini computer or your calculator.